Aloha, everybody. So everybody go home and try to say this 5 times real fast. I won't make you do it here. Okay. Again, I'm Brad Romine, coastal geologist and coastal management specialist with the University of Hawaii Sea Grant College program. I work in a cost share position with the state of Hawaii at the Department of Land and Natural Resources, where I support their beach management efforts, beach conservation and restoration. If somebody has a beach erosion problem, we're often the first ones that get the phone call. Also working with them on some longer range initiatives, including developing a statewide sea level rise vulnerability and adaptation report, which I'll talk a little bit about. Oh, sure.
Where was that beach?
That is Sunset Beach on a calm, very calm, nice day. And that's what we wish all our beaches look like, right? Unfortunately, we're going to see a lot of beaches that are in much worse shape in this talk. And actually, Sunset is looking not so good right now itself. You've been out there lately. The bike path has gotten undermined by erosion recently and partially collapsed. So that's a good day out there. So in a real general sense, kind of the crux of the problem is that we've built too close to these highly hazard-prone shorelines. On your left, there is a home at near Sunset Beach there, Rocky Point area, from some erosion in 2013. That's all beach sand directly underneath that house. In fact, the whole stretch of beachfront homes along the North Shore are built on what looks like a sand dune. It's really a high wave berm. It's been built up over probably hundreds of years, and we've chosen to develop right up on top of it. The one on the right is at Kailua Beach, I believe, during a big, unusual easterly swell that affected that area. So we've really left our communities vulnerable to coastal hazards, high waves, flooding, wave overwash. We've also really affected our natural beach environments, which don't end right at the vegetation line. These beach environments include the nearshore reef and the sand deposits off there, and extend across the dry beach and up into the backshore dune areas. We know from some of the studies, including some that I've been involved in, that the vast majority of our beaches around Hawaii are eroding. On the order of 70% of our beaches on Kauai, Oahu, and Maui. It varies some among the islands. Maui has significantly more erosion than the other islands. About 85% of beaches on Maui are eroding. If you look at the overall average erosion rates among those 3 islands, our beaches have eroded about 33 feet on average over the last century. May not seem like a lot, but for Hawaii, our beaches are typically fairly narrow, especially when you compare them to a mainland setting. And also when you consider the minimum setback, the minimum construction setback in Hawaii, which is typically 40 feet, but sometimes as little as 20 feet. So you start to get an understanding of why we have all these homes and critical infrastructure and roads being affected. We have road problems on all our islands. Here's just some examples on Kauai. Here, I had a pointer. There it is. This is these 2 are along the northeast side of Kauai, east side, Kapa'a side. This is on the west side near Waimea. Maui in particular is really suffering from some dramatic erosion, particularly along the West Maui resort areas. This is the Kahana Bay area. Both of these 2 resorts of several that have been highly threatened by beach erosion over the last few years, actually the last decade or more. This is the Kihei side, a home in the Halama Street area, and then up on the North Shore in the Sprecklesville area. So widespread erosion problems there. One that you may remember was this dramatic erosion we had at Sunset Beach, 2013, 2014, that winter. Really kind of case in point of the vulnerability of our homes along the shoreline. We had some unusual wave directions that affected this area over that winter. And in a matter of days, completely scoured out the beach in front of this area. We lost the backs of several homes, extensive areas of the backyards and all that. And luckily did not lose any entire houses, but at least one home lost a back bedroom, several lanais lost as well. We've been, through the state, have been working with the homeowners in that area to restore the beach. Once it recovered, they've been using heavy machinery, bulldozers and such to push the dune back in place. And that's worked pretty well in that location. Then in general, our coastal highways are a real challenge for us. Honolulu, Ka'ava, maybe you've probably driven that area. Ka'ava in particular was damaged by some erosion during the winter. This again is the west side of Kauai, the coastal road through there. I had to throw this in today. I don't know if any of you saw the news story on that. This is Hanoa Pi'ilani Highway at Oluwalu on the way up to Lahaina. That's a monk seal right there. They crawled up on, this is sand during the high tide. So we're entering the king tides now. I'll talk some more about that. There are annual high tides of the year. This is the highway running up to Lahaina. You can see the overwash and the sand encroaching onto the highway here. And these are cars and a monk seal that has actually tried to crawl up and find dry beach and has ended up on the highway there. So shocking, fascinating from a geological standpoint. Seeing beaches do what they should do from a geologic perspective, and that is migrating up and back with rising sea level, and that's a big part of what's happening there. The State Department of Transport's approach has typically been to dump rock and protect the highways, but that's led to extensive beach loss throughout the islands. Oh, my 45 minutes isn't up already. Okay, good. I got a ways to go. All in all, coastal armoring has contributed to about 13 miles of beach loss in Hawaii. The way this works is you put armoring typically on the back of a shoreline to slow the erosion, protect the property. But on a chronically eroding beach, the waterline will tend to continue to creep towards the armoring. And in many places where you have this chronic erosion armoring, you ultimately lose the beach. And this is kind of a prototypical example at Lanikai here on Oahu. So what's causing all this erosion? We know that sea level rise is one important component of that. From some of the research I've been involved in at UH Manoa, it's not the only factor. When you look at the localized issues, other causes of erosion include the natural sediment processes, how much sand is available to the individual beach system or littoral system. Seasonal waves and storms have a high impact on our beach variability here. As you know, we all get very large waves during the winter, particularly on our north shores, but also our west side in the winter, and big south swells affecting our south shores in the summers. And then, as I just shown you, coastal engineering and shoreline armoring can have impact on our beaches and coastal environments if not planned and located properly. Beaches, coastal environments, and shoreline access are protected by law in Hawaii. This is through, in a general sense, the public trust doctrine. This is something that goes back even to Roman times, that certain resources are preserved by the government for the public's use. The Hawaii State Constitution provides broad protections for our beaches and marine and shoreline resources, guiding us to conserve and protect Hawaii's natural beauty and all its natural resources. The Coastal Zone Management Act directs us to preserve and, wherever possible, restore the natural resources of the coastal zone. And then the Department of Land and Natural Resources, among other agencies, has its own rules. And for the DLNR, it's our conservation district rules, which guide protection of important natural and cultural resources, which include our beach resources and coastal environments. Protecting these resources is further complicated by overlapping jurisdictions here in Hawaii. Shown here is some of the agencies that have jurisdiction over our coastal zone here in Hawaii. The agency I work with, the Department of Land and Natural Resources, is responsible for the beaches and submerged areas out to the state 3-mile limit. And that's from this boundary, the certified shoreline that I won't go into in this talk, but it's roughly at the vegetation line. It's the high wash of the waves, and it's determined on a case-by-case basis. Landward of that boundary is the county jurisdictions. The counties have permitting authority within this special management area along the shoreline for any construction building in that zone. And then the Hawaii Department of Health, as well as federal entities, including the Army Corps of Engineers, have some regulatory jurisdiction from the high water line seaward. So it makes management, it makes permitting for all sides more challenging, trying to deal with all these myriad issues we have at our coastlines. And with that, with coastal erosion, with sea level rise, these jurisdictions are migrating landward as well, further complicating the regulatory regime. So I think you got in the picture. Coastal erosion and flooding are already serious problems here in Hawaii. Begs the question, then how severe will it get in the future with climate change and sea level rise? And further, almost more importantly, what can we do about it? We have blown past the natural background CO2 record. We're now at the highest CO2 levels in 800,000 years, possibly as long as 4.5 million years. We know this from ice core records from Antarctica, Greenland. And this is resulting from input from burning, releasing greenhouse gases from burning petroleum, land use changes, industry, energy, transportation. And as a result, global air temperature is increasing. This is temperature averages from 4 independent research organizations around the world, and it shows a steady increase in temperature from the early 1900s up to the present as a result of greenhouse gas emissions. What effect is this having here in Hawaii and the Pacific Islands? A good reference, a good read is the Pacific Islands Regional Climate Assessment. And they document a number of changes that Hawaii is being affected by due to climate change. Changing rainfall patterns, changing extreme events, storm events, surface air temperatures are rising, ocean heat context, the ocean heat content is rising. The oceans are taking up a lot of the heat from the atmosphere. Ocean chemistry is changing. It's becoming more acidic, making it harder for corals and other shell-forming organisms to make their shells. Stream flows are decreasing. And sea level is rising, which I'm really going to focus on the sea level rise issue because that's where my work is focused, and I think one of the main concerns here for Hawaii, but certainly not the only one. Looking at this is a plot of global sea level rise since the early 1900s. The trend in blue here is from tide gauges around the globe, averaged together. The red, the green line fit to it is from more recent satellite altimetry data. The rate has accelerated over the last century from about 3 inches per century in the early 1900s, doubling through the mid-century. We're now somewhere between 1 foot and 1.5 feet per century equivalent rate of sea level rise. And we expect that rate of sea level rise to continue to accelerate with continued warming. We also observe sea level rise around Hawaii. You can see that in this upward slope of the long-term trend of sea level rise from the Honolulu tide gauge here since 1900. What is contributing to sea level rise? There's 3 main components that are adding to the water levels globally and around Hawaii. The first is thermal expansion of water. As it warmed, it actually expands to a certain degree, and that's roughly a third of the rise that we're observing right now. Land-based glaciers and ice caps are contributing about another third of that, and then separated out from that, Antarctica and Greenland, the large continental ice sheets on those are contributing to another third of the sea level rise we observe. Greenland and Antarctica are losing ice at increasing rates. Here's some plots of ice mass loss from NASA's GRACE satellites, which measure the gravity of essentially the weight of ice on those continents, and you can see this decrease in ice mass. And if you were to fit a curve to that, it would actually be bending downward, showing a increasing rate of change in ice mass loss from Greenland. Similar trend from Antarctica. So looking ahead, what does this mean for sea level rise in the future? This is one projection from the Intergovernmental Panel on Climate Change, their sea level rise curves from their AR5 report in 2013. They provide two curves in this. This is from 2000 out to the end of the century. Meters on the left here, again, 1 foot roughly, or 1 meter is roughly 3 feet, of course. They provide two scenarios here, what they call representative concentration pathways. The blue one is their scenario is if we were to dramatically reduce greenhouse gas emissions in the coming decade. The red one is what's generally referred to as the business as usual scenario, if we continue to pump out greenhouse gases at increasing rates. And they have the lines, they have an uncertainty with that. You can see the uncertainty increases with time. That's due in large part to uncertainties with these scenarios, not knowing exactly how much greenhouse gas we'll put out. Also, we need to improve our understanding, continue to improve our understanding of how ice sheets are behaving to this warming. But if you look at that high-end scenario, and this is the one that we're using for the state sea level rise vulnerability and adaptation report that I'll talk about, it points to about 1 foot of sea level rise by the middle of the century, and as much as 3 feet of sea level rise or a little more out towards the end of the century. That's not the only sea level rise projection out there. There's a number of them. This is one that came out recently from the National Oceanic and Atmospheric Administration technical paper. They provide a number of scenarios here, including one up to over 8 feet. And what was particularly alarming with this study is they pointed to a physically plausible global mean sea level rise in the range of 2 meters or more, possibly 8 feet of sea level rise, physically plausible. That's a low likelihood scenario, but plausible if we continue on the path we're on right now, and if ice sheets behave like some scientists are saying are possible. I'm sorry? Feet on the right-hand side, right, meters on the left-hand side. I'm sorry? Oh, it looks like a minus. Yeah, I think those are tick marks that didn't come through. Yeah. Right. For comparison, the IPCC projections I showed in the previous plot fall somewhere in the middle of this report. In fact, that's the high-end IPCC projections, which come from a global consensus of scientists and policymakers, fall in the middle of this NOAA projection. So the sea level rise forecasts continue to evolve with the science and will continue to evolve. Again, the IPCC plot that I showed you represents a broad consensus of an international group of authors and reviewers. NASA came out with a somewhat alarming statement in 2015. Given what we know about how the ocean expands as it warms and how ice sheets and glaciers are adding water to the seas, it's pretty certain we are locked into at least 3 feet of sea level rise and probably more. The question with that is the timing. When do we see that sea level rise? Do we see it right at 2100? Do we see it earlier in the century, or can we do something proactive and hold that off until later in the next century? And as well as recent results from ongoing science regarding Antarctica and Greenland ice sheet instability, indicating that higher end scenarios are more likely than previous thought. So sea level rise, I've touched on some of these impacts, but it can lead to increasing severity and extent of coastal erosion, wave flooding, groundwater inundation, drainage failure, and hurricane and tsunami vulnerability, meaning that if you have higher water levels underlying when these intermittent events come through, the impacts are going to be higher. So how do we address this? Well, climate change requires a two-pronged approach. The first is mitigation, making interventions to reduce the human-induced cause of climate warming, reducing greenhouse gas emissions primarily. And then the other prong is adaptation, which I'm going to focus on mostly here the rest of the talk. These are adjustments in response to actual or expected climatic or environmental impacts. But briefly on climate mitigation here in Hawaii. To begin with, Hawaii is the most fossil fuel dependent state in the nation. Has fairly recently committed to doing its part on the mitigation end. This includes the Hawaii Clean Energy Initiative in 2015, which is directing the state to move to 100% renewable electricity generation by 2045. The state also, you probably saw some press on this, and just a couple weeks ago, passed this the governor signed House Bill 559, which commits the state to combat climate change in alignment with the principles of the Global Paris Agreement to reduce emissions with the goal of keeping temperatures below 2 degrees C. So moving to the adaptation side, the side that I'm primarily working on, in 2014, the state passed the Hawaii Climate Adaptation Initiative Act. This was State Act 83 of that year. With that bill, they found that climate change is the paramount challenge of this century. The primary purpose of this act is to address the effects to protect the state's economy, environment, and way of life. And the initial focus of the act is to address the impact of sea level rise, recognizing that there'll be other impacts from climate change, but given the science we have available, the impacts we're already dealing with, erosion and other hazards, the state agreed to focus on sea level rise first. And with that, we're developing a statewide sea level rise vulnerability adaptation report for the state of Hawaii, which is due to be completed at the end of this year. So going into some more detail about that statewide sea level rise vulnerability and adaptation report. This is a partnership with this Interagency Climate Adaptation Committee, co-chaired, co-led by the State Department of Land and Natural Resources and the State Office of Planning. We're working with a consultant, Tetra Tech, as well as researchers at the University of Hawaii School of Ocean, Earth Science and Technology. We're doing hazard exposure modeling. I'm sure you can't read that. I'm sorry. I'll just let you know what we're looking at here. We're modeling sea level rise hazards and mapping coastal erosion, passive flooding, annual high wave flooding, as well as looking at 1% annual chance coastal flooding. And I'll show you some of the hazard maps from those in more detail. Collecting all the geographic data, census data that we can get our hands on, and doing a vulnerability assessment, what's vulnerable based on these hazard assessments. And then conducting a vulnerability assessment, looking at potential loss and displaced people, impacts to cultural resources, and primarily looking at economic impacts potentially to the state over the coming century. And then compiling those in a report, producing maps and graphics ultimately delivered to the state at the end of the year. Some of the work that's been done at UH, this is a paper by Tiffany Anderson at the University of Hawaii Coastal Geology Group. She found with her study in developing a model that looks at historical erosion trends and also some models of how our beaches should behave with sea level rise. Found that erosion will likely double under sea level rise by the middle of the century. She found that 92% of our shorelines are projected to be eroding, that is retreating by mid-century. And we're using that model that she developed to map erosion hazard areas around the state with sea level rise. And here's some outputs from just some examples from that model. This is Honolulu along the northeast windward side here. That green line showing there is the present shoreline, or approximately the vegetation line, and we're projecting the erosion hazard based off of that. Here's what it looks like with 1 foot of sea level rise. This, I should mention too, this is an area that's undergoing chronic erosion now, and will only increase in the future. It's a real problem area for us at this time, and will only be increasing so in the future. 1 foot of sea level rise, the yellow line, 2 feet, the orange line, and 3 feet with the red line there. And We're doing this statewide, but primarily for Kauai, Oahu, and Maui, where we have really good historical erosion data for those islands. We're also looking at impacts from different kinds of flooding, including this kind of recurring flooding, passive flooding, and wave-induced flooding. This is just some examples of some of the recurring flooding that we're experiencing right now with the king tides. I'm sure you've seen some of the press on that. I'll talk a little bit more about that towards the end of the talk. This is a plot of the long-term sea level record from the Honolulu tide gauge. You can see the long-term trend in red there, but also there's a high degree of variability in there from climatic variability, oceanographic variability. But we see these peaks in here that are increasing. They're happening more frequently, and they're happening at higher level as base sea level rise increases. And that's leading to flooding like this. This is in front of Waikiki, the Halekulani Hotel, overtopping the back of the beach here into a walkway that's actually below the back beach level. This is the other end of Waikiki towards Publix Beach and Queens Beach in that area, overwatching the path here. Another study from NOAA found that with only 14 inches of higher sea level, most locations 5 times more frequent flooding than present along the coastline. So we're looking at more and more of this kind of recurring flooding along our coast. And that could occur as soon as just a couple decades with sea level rise. So we're working with the UH Coastal Geology Group to model a couple flooding hazards with that. The first is what we refer to as passive flooding, or it's often referred to as a bathtub model, where we just raise a static water level in a model over digital topography models. And this is just kind of describing what we do, raising the water level from this blue line up to this red line at a certain sea level increment. And it shows the flooding along the low-lying coastal plain. It also shows where the groundwater table will crop out, where it's non-marine flooding, where we actually have reduced drainage and new wetlands forming with sea level rise, and the water table is rising with that. Here's some results from those models. This is the Alawai, Boat Harbor, Magic Island, Ala Moana, Hilton, Waikiki area. This is 1 foot of sea level rise from the UH model. Rise, I should point out here too, the blue is direct marine flooding. This is water coming directly in from the ocean. The green is indirect flooding, not directly connected with the ocean. This is actually groundwater that would be cropping up out of the coastal water table. It could be some of both. So it could be cropping out of the water table, brackish or fresh water. It could be coming out of the storm drains, which we're seeing with a lot of these high tides as well. In fact, we have Shelley here in the office, or in the audience here from the UH Coastal Geology Group, who's a local expert on that. So sorry to single out, but if we get any more questions on that, maybe she can share her expertise with us on that later. And then this is 3 feet of sea level rise, and you really start to see the marine inundation start to creep into Waikiki. In this area, Hilton Lagoon area, a lot of that would be coming up through the drainage system. And it's interesting to note, I'll back up here a little bit. This is just 1 foot of sea level rise. This model does not account for wave overwash. I was down at this area at the last highest tide last month, and there was water pouring over this beach into the lagoons. So you add in waves and it becomes a lot more severe. And so we're trying to model that as well in this next model I'll show you, which we refer to as annual high wave flooding. So we're out here in the middle of the Pacific. Hawaii is highly vulnerable to waves from all directions, particularly our north shores in winter and our south shores in summer. This time of year, University of Hawaii has developed some models with others to model an annual high wave. So this is an average annual high wave. They're taking buoy data from offshore, statistically calculating what is your typical annual high wave for a stretch of shoreline, and then modeling that wave across the offshore reef and modeling the run-up on the shoreline at various increments of sea level rise. And I'll show you some examples from those models. This is the Eva Beach area. At present day, on your kind of typical annual high wave event, this would be a south swell for this side. Here's 1 foot, not a lot of impacts in this area at that. The seawalls in the back of the homes at that level. 2 feet, we start to see some of the wave action here in blue, these fingers of waves running up into the communities now. And then 3 feet, really dramatic wave overwash starting to creep into the community. And this 3 foot threshold seems to be kind of a critical threshold for Hawaii. It's kind of a typical elevation we find for the back beach berms along our coast. And we noticed with a lot of models, once things kind of crest over that elevation, we saw it also in the passive flooding model, that things really accelerate and get really bad at that threshold. And then, so we're also doing this vulnerability assessment with the state's consultant, Tetra Tech, and they're combining those hazards, erosion, passive flooding, and the wave overwash into a single hazard exposure area for the purposes of vulnerability assessment. So adding those up into a combined sea level rise exposure area, which they're then laying over other layers of homes, census data, critical infrastructure, looking at what's potentially vulnerable. And this is what an example of what some of the maps look like that they're producing. This is the east side of Kauai, Kapa'a area, showing structural economic loss at 1 feet of sea level rise. These have been compiled up into 1 hectare grids for the purpose of this mapping, and you can see the different values for these grid cells, up to as much as $5–10 million for some of these hectare square areas in home loss and in economic loss. And this is what it looks like with 3 feet of sea level rise. So these maps will be produced with the state sea level rise report in a online web viewer that I'm going to talk a little bit more about in a minute. And with the report, we'll have a number of graphs and figures compiling up all the results, primarily at the county and statewide level. So I'm going to briefly touch on this, but what can we do about all this? What are our adaptation strategies for this? They're often described in 4 kind of major categories. The first is protection, hardening our coast. This generally prioritizes protecting people and property over our natural environment, but it's certainly one approach, and one that probably take more in a lot of our developed areas, like South Shore of Oahu is largely armored already. So probably continue that approach in places like that. Accommodation, this is allowing for continued development, but requiring buildings to be constructed or retrofitted for improved resilience. And the county of Honolulu is actually doing a study where they're looking at the building codes and how to improve resilience to coastal hazards and climate change through the building codes and things like this, elevating structures, making things more resilient to coastal hazards, which are increasing. There's other approaches like planned retreat or realignment. This is effectively moving back from the coasts in areas where we want to prioritize beach or coastal resource conservation over private lands, but obviously very fiscally, politically challenging. The State Office of Planning has a project right now where they're looking at kind of an initial discussion about how feasible this may be in Hawaii. And then preservation. This is preserving and restoring some of our coastal environments that aren't yet highly developed for their ecosystem value, as well as a natural buffer to coastal hazards. Beaches in their natural state, as well as the wetlands, are as effective as anything at reducing wave damage from storms and high waves. So it won't be one of these approaches, one size fits all approach. It requires a toolkit, mixed bag of different adaptation options appropriate to the local setting and appropriate to our community's priorities. I'm going to touch on some of the work we're doing to build on the state's climate adaptation initiative. In 2015, NOAA started a new grant program, the Regional Coastal Resilience Grant Program, and partnership with Natural Resources and the State Office of Planning. some grant funding and received a nice grant from NOAA, close to $1 million to do some additional hazard planning work and add-on projects to the state sea level rise report. And the first project it's supporting is this web-based hazard exposure and vulnerability mapping tool that we're developing with the Pacific Islands Ocean Observing System. This will be a web-based tool. It's effectively, it's an example of a screenshot from that. It's effectively a online atlas that will be available with the state sea level rise report to explore the data more for your areas of concern, look at the hazard and vulnerability areas around the Hawaii coast. The second project we're doing is developing some guidelines for how to better integrate this data and the recommendations and other tools that have been developed for sea level rise primarily into our community plans and general plans. These are the plans that guide development in our communities primarily at the county level. And then the third project we're doing is building on some work that Maui County did and Sea Grant did to develop guidelines for post-disaster rebuilding and recovery. How do we better recover following a disaster, hurricane or tsunami or extreme high wave event? How do we redevelop after that so we're more resilient following it, for future disasters? We're not making the same mistakes and building back the exact same way every time. Another initiative I wanted you to be aware of, I'm not directly involved in this, I just wanted to make sure you're all aware of this, is City and County is also increasing its work in coastal resilience and received a grant through the Rockefeller Foundation, this 100 Resilient Cities program, where they have hired a resilience coordinator, brought together this City Office of Climate Change, Sustainability, and Recovery. And they're looking at a range of resilience and sustainability challenges. This includes infrastructure issues, economics, coastal storms and other hazards, aging infrastructure, homelessness, rainfall, but also looking at sea level and coastal erosion. In fact, they had a big kickoff meeting. I don't know if any of you were able to attend that a couple weeks ago. And part of it was to introduce this new office, the new resilience coordinator, Josh Stanbro, but also to help them set the agenda. And housing was one of the things that rose to the top, but also coastal hazards, coastal erosion, flooding, and a lot of the issues that I've been sharing here with you today was the other thing that as a whole, collectively, the audience kind of singled out is one of the things they really want this office to focus on. So it's nice to see this growing focus from the states and the counties on these really challenging issues. So I want to talk briefly about the king tides that we're experiencing right now. And you've probably seen some of the press last month. Today there was a number of articles. There'll probably be a couple more in the next couple of days. Right now we're experiencing the annual high tides, annual lunar astronomical high tides of the year. In itself, that's nothing unusual. We get that every year this time of year. It's just a particular alignment of the moon and sun this time of year. What's particularly unusual this year is that we have these elevated water levels on top of that, 6, even as much as 10 inches of water level since early 2016. And you can see that in this plot from the Honolulu tide gauge. What this is over the last couple days, showing the height on the Honolulu Harbor tide gauge in feet here. The blue line is predicted tide height, just from the lunar tides. The red line is what's been being observed at the tide gauge, and it shows that consistent 6, 8, even 10 inches of elevated sea level we've seen statewide since early 2016. So what's causing that? In large part, it's this anomaly, this bulge of elevated sea level that we've seen around Hawaii for the last year or so. This is a plot of sea level anomalies, just basically the deviation from the average sea level. Sea level around the globe is not a constant surface. It does vary due to currents and climatic natural variability. And the elevated heights are shown here in red. The decreased heights are shown in the cooler colors. You can see this. This is not temperature. This is elevation of sea level height, this bulge of elevation around Hawaii. And this this bulge has been persistent around Hawaii since early in 2016, and it's probably related to, well, we know it's related to through the UH Sea Level Center and other researchers at UH from just some variability that we get, Pacific-wide variability known as Pacific Decadal Oscillation. Maybe some lingering effects of El Nino from the past couple of years that have slowly made its way up into Hawaii and through the Central Pacific. But the sea level rise, we're also, the recent sea level increase we're seeing also have a component of the global sea level rise in them too. We're asking folks to go around and help us document rise events. We have the highest tides. These are often known, again, referred to as king tides. It's just kind of a catchy name for the highest tides of the year. They're happening this Friday, June 23rd, and Saturday the 24th in the late afternoon, around 4 or 5 o'clock here in Honolulu. And then again later in July, similar tide heights, 21st and 22nd in the late afternoon. Sea Grant has developed an app, a tool that you can load onto your smartphone, iPhone, whatever you got there. Take a photograph. We're looking for people to help us document these high tide impacts. Here's some of those we've gotten from folks the last couple of years. This is Waikiki Beach being completely overrun by the king tide high water levels. That is actually waves coming down a storm drain near Fort DeRussy, which is 100 yards or so seaward that way, coming down the storm drain and splashing up through the storm drain at the highest tide. That's sand. I know Chip Fletcher likes to say that's trying to make a beach right there. That's sand coming down the storm drain and shooting out there and landing in the street there. This is the area of Mapunapuna. Probably seen these photos. Flooding, that's salt water. It's flooding in that area during the king tides, overwash Ala Moana. So these are photos collected through that program. So hoping some of you might go out and branch out the next couple days during July and snap some photos for us, upload it through our King Tides program on the app or the online program through these websites. Why are we doing this? In summary, today's extreme tides are tomorrow's average water levels. It gives us a snapshot, a glimpse at what our future looks like in a few decades with sea level rise. And it's helping us to understand, better prepared for the impacts of sea level rise, helping us identify what it's going to look like and what some of those vulnerable areas look like, as well as validating some of the modeling that folks at UH are doing and elsewhere. So thank you very much again for being here tonight. I think we have some time for questions. Yes, please.
How are we getting more or less vulnerable to rising sea level waves?
That's a good question. We don't have a lot of good historical data, at least on shoreline change for Kaneohe. We didn't model that as well. No, we're doing modeling for that area. At least we're only looking at the passive flooding model for that area with the state sea level rise report, because unfortunately we don't have the historical erosion data, so we can't do the wave run up model, can't do the coastal erosion model with that. But from my memory, the topography is pretty variable in there. You have places like Heia, which are pretty low lying, wetland type areas that'll be pretty vulnerable. And then other more, rocky, vertical areas that'll be less vulnerable. To be seen with the modeling to come on this. I haven't really looked at it closely. One question it begs is the wide fringing reef there. How healthy will that remain with changing ocean chemistry? But also, will the reef there and elsewhere be able to keep up with sea level rise? If not, that means increasing wave energy could get across the reef and increase erosion at the shoreline there and elsewhere. I saw another question from you, sir. Anybody else? No? Okay. Yeah.
So, yeah, if you score, I don't know that of the life cycle of the islands, I mean, it occurs over years. Sea mountain island and capital. Basically, erosion is kind of natural, but it occurs over years. So, how do we balance that concept with what we're facing here today, where basically, on adaptation, protection for the so how do we like this long-term future in mind? So also covering the problems that we
So you're right on geologic timescales, times of like millions of years. The islands do grow up, with the volcano. Big Island is adding more and more mass every day. They slowly head off the hotspot and they sink. So that's on geologic timeframes. What's exceptional with what we're dealing with right now is happening on human timescales. The rates of change are well beyond what we would expect on a geologic timescale. So.
how do we know? Is it just through the climate change stuff like IPCC?
Yeah, that's so.
How do we know that those aren't just normal? We had those
So there's a certain degree of that in what we're observing for beach erosion. So one of the studies I was involved in was looking at the difference in beach erosion rates between Oahu and Maui, and actually Maui is sinking, it's subsiding somewhat faster than Oahu, and that results in a somewhat higher relative sea level rise rate for Maui. So that's a natural component, and it's to what you're talking about. So it's part of what's contributing to the increased erosion on Maui, we think, and but it also makes Hawaii kind of a good natural laboratory for sea level rise. We have these varying relative sea level rates among the islands, and can kind of use that to look at the different erosion rates. So yeah, it's a good point, and it is a component of what we're observing with human caused changes. Yeah. Yeah.
You said that more than half of the beaches are going away. What about the other half? Is it not decreasing, the beaches that are moving, they still shrinking, which is what's happening?
Yeah, it's the question, if you didn't hear, is so as he said, about half of the beaches are eroding. It's actually more like 70% of our beaches among Kauai and Oahu are eroding. What's happening on the other beaches that are stable or accreting? So there are some exceptions to the erosion. Kailua Beach being one example that is steadily gaining sand, at least over human history. We see the beach growing out there. We see these incipient dunes. Honolulu Bay on Kauai is another example. There's a few of these around the islands. With the modeling, what that shows us is, we do expect some of those to continue to grow, accrete over the short term, over a few decades. But eventually that accretion should level out and turn to erosion. It just depends on how much of that sediment is able to continue coming in. So there's some unknowns there, but the report I showed you from Tiffany Anderson at University of Hawaii showed that we've got about 70% of our beaches eroding, expecting about 90% of them to be eroding by mid-century if these sea level rise scenarios. So that means a lot of these pockets of accreting beach will turn to erosion in that time frame. Any other questions? One in the back there.
What's your thoughts on using artery, shoreline, footline? So a private property owner does that, or maybe government does that, but downstream, downflow, it could adversely affect someone that wasn't affected originally, but because someone put a big seawall or a big rock funker, now someone downflow is adversely affect. How is that being discussed in front of people's responsibility?
So that's a very important point. I didn't get into, but one I deal with on a daily basis with my work. It's often referred to as flanking erosion. You put one seawall in, it tends to increase the rate of erosion on the neighboring shoreline as it disturbs the sediment flow, but also things like waves wrapping around the end of the structure. And it often leads to this domino effect. One seawall goes in, another one has to go in, and get this domino effect down along the shoreline. So it's something we're very conscious of. It's something the state is aware of and the counties are aware of, and why they're very careful in review of any coastal armoring structures along the shoreline. It's a real problem. It's not just beach loss fronting the walls, but increased rates adjacent to them. Yeah, it's a real problem, and good point.